I'm Alan and welcome to Enots Engineering. In this week's episode we'll continue making the drill grinding fixture. This week we're making the base plate. This is the base plate. This one's made out of aluminium, but it needn't be made out of aluminium, it can be steel. It involves some faceplate work, machining a radius and a bevel, marking the zero position, and also thinning out some of this material. So let's go into the workshop and see how we did it. I've marked the centre line, positions of the holes that I want to drill. There, there, there and there. I've put it on the centre. I've zeroed my table to that position because that's going to be the dowel hole. So all the other holes will be marked from there. I've got an offcut of MDF. I've drawn a line down, marked the position of a hole, drilled the hole, and I've found this screw which will fit in there, that being the datum holder I'm using. So I'll just screw this onto there. Doesn't need to be tight, I'm just using that as a pivot point. So now I'll set my block. Let's clamp it up. There's the centre line there. Bring that in front of the blade. Just check that the teeth come onto it. Lock up the piece of wood. Now I've got a pivot point there, so I'm going to switch the saw on, see if I can cut through that. I've just put this piece of MDF in the chuck jar. I want to make a bung that goes in the centre of my faceplate with a 5mm hole through. Just touch it onto the job, wind it in, and it trues the part up. So now I can just nip that up. The part's running true. And all it is a bar and a small bearing pressed on the end. You bring that in, the bearing touches the job and taps it true. The only thing you don't do is tighten the chuck up fully, you just grip it lightly, true it up, and then tighten the chuck up. That's coming out at 33.9, nearly 34. I think I just need it just under 33. .33, that'll do. I just want to face it off so I know it's square. What I've done with this base plate is put a 5mm peg in there. That's a 5mm hole. I've just tapped it into the centre, so when that goes in, that gives me a line up. Now all I need to do is put some clamps on the outside so I can turn this radius true and put a bevel on there and mark up the centre line. This is how I've bolted this down to the faceplate. What I'm going to do is machine the outside of this with a chamfer on, but I want to reduce this flat surface here by 5mm, so I'm hoping I can turn this at the same time. This piece is clamped with the two triangles, and this here is a piece of packing just to get the same height, and at the back there's a piece of packing. So I'm bearing in mind when this is going round that if this comes loose, these two pieces could fly out. The centre piece won't because it's held in with the dowel in the centre, and these are held in with nuts. Also the component is up against this bolt, so that as this comes around and the tool's cutting that way, any force is pushed up against that bolt so it won't turn. And now I fitted the faceplate. The first thing I need to do is mark the centre so I can then measure the diameter that I'm turning. What I want to do is turn this diameter on the outside down to the correct size, which is 118 millimeters from the centre. Put my tailstock in with the centre drill in. I've moved my saddle across. I'm just checking that the part doesn't hit the saddle, which is clear. Move the tool out of the way. It doesn't need a deep hole, it's just to mark the centre. And what I've done is I've had to change this plate that was here. It was a smaller plate. It was that plate, because this end there was a gap underneath, it wasn't pulling down. So what I want to do first is machine this down to 5mm thick, that area there, and then machine the rest down to the right diameter and put a bevel on there. I've checked that my tool is going to be clear of these clamps. So that's the furthest I want to go in at that point. That clears everything. So that's So the next thing I need to do is change the clamp and then machine off 5mm off this face. That's that. I put a screw cutting tool sideways in the tool holder. I've zeroed the tool level with this line that I marked before. Moved it to the edge, and using the compound slide, just go in and score a line down the side there to be a 0 mark, which is there. Look. So that's finished. We've machined it to diameter here, put a chamfer on there at 30 degrees, machine the face 5mm lower because I need the space, and that block's finished. I'll bring you up to date. The two 5mm holes that were in the base I've just countersunk to accept a 5mm cap head. The spindle block I've drilled and tapped two 5mm holes. So this is the original tool holder with the cutter grinder. So I'm taking that off, and this one will go on. I need to put a 6mm dowel in there, which will fit in the hole there, and that'll fit about there, so it can swivel with the degrees each side. The plate will tilt up and down for the angle of the cutting edge. Locking screws will fit in there. That's the locking screw from the existing fixture. It's just a spindle lock there, and we also need to make the spindle. So the next thing we need to make is a 6mm pin. A piece of silver steel in a chuck. It's about 8mm. I need to bring this down to 6mm to make the dowel for the location pin. Point 265. Point 237. A thou over, I'll leave it at that. And before I part that right off, I want to put a chamfer on so that I can tap it into the hole. And that's the 6mm dowel. I'll fit that in the fixture. There's a 6mm dowel fitted. That locates on the table on the cutter grinder. We've also machined this radius on here and put the 0 position there with that mark. So this will match up with the angle on the table. We've countersunk the 2 holes underneath so that they're flat with the surface, so that can sit flat. And these 2 holes come up inside the bore into the cutout that we machined, so that the burr on the inside doesn't affect the spindle bore. I'm just planning out how to machine the spindle without having too many changeovers, so I've decided to cut it between centres. That way I can machine the thread and the spindle diameter in one operation between centres without having to change anything. So the first job will be to machine the face, centre drill it, drill the bore out with the drill, and then recut a cone for a centre. And then on this end, turn it around in the chuck, face it off, centre drill it, drill this bore out with the drill, and recut a cone for the centre. Oh well, that's it for today. I'll start making a spindle on the next episode of Enots Engineering.